This scene, we talk about 215,000 meshes just for the grass. Even though I'm currently running on 4090 graphic card, you can see as closer I get, the faster, further away I go, it's slower. But that's something quite obvious because we're dealing with lots of objects on the scene.
Hi, and welcome to the TD Meetup. My name is Alexander Richter. I'm a technical director for visual effects, animation, and games. And I work at companies like WeatherFX and Framestore on Avatar: The Way of Water and Monsters at Work.
We want to look into procedural content generation with Unreal. And I'm not doing this alone, this whole event. I'm joined today by Paul, who is an Unreal generalist, who is also an educator, and he's currently wrapping up his book about Unreal and PCG framework. And if you're wondering if Paul looks exactly like his older profile picture from like 2 days ago, I think you will find out in the middle of the presentation, basically. The structure is, I will do the introduction to PCG, what it is, what exactly does it entail, and I will focus mostly on the general idea of PCG. Then I will give over to Paul, who will look at the PCG Unreal framework specifically, so how to use it in Unreal and how to generate content there. And then at the end, we do our Q&A, where first I will do a few questions that I had when I started to look into the topic, and then we will open the floor for everyone to join. And you can ask the questions. So if you find something during the presentation that you feel like, oh, this would be something you would like to know, note it down or write it in the comments, basically in the messages, and then we will tackle it later at the end of the event. The first question that we need to ask ourselves in this event is basically, what is PCG? And the simple thing is, PCG is an acronym for Procedural Content Generation. And we always want to define what that exactly means. Is in computing, procedural content generation is a method of creating data algorithmically as opposed to manually, typically through a combination of human-generated content and algorithms coupled with computer-generated randomness and processing power. So if we take this example, this is an environment in Unreal. This is an example of what that means between manually and computer generated. On one side, there is maybe someone who created some of the trees, some of the stones, some of the elements in the scene. And then on the other side, you have algorithms who basically distribute things, put things, change things, modify things to create this whole environment. So you have the mix of manual elements of sculpting and modeling and shading and whatever. And then you have the mix of distributing, modifying, and so on and so forth. And that is the combination that PCG often lives on. So it's usually not fully algorithmic. It's often combined with manual work. If we talk about PCG, what kind of content can we expect from it? A very typical thing, and that's something that we'll focus also today when we look into Unreal, is specifically landscape generation. Landscapes are vast fields. You have a lot of stuff in there. So it's nice to have, the mountains and rivers and whatever. So that's really cool. And it allows us also to modify the landscape to certain, environments, seasons, climate, shape, and change, and so on. So we don't have to, create a landscape, change it for autumn, change it to winter, change it to. We can also use the PCG to do that as well. Obviously, a landscape is relatively boring. We need stuff. So generating forests, rivers, generating cities, and generating, obviously, filling it with characters, animals, and so on and so forth. Obviously, we can do it manually, but with PCG, we can distribute it and put it basically algorithmically. It's not only modeling elements, it's also things like shading and textures. And it's not only shading and textures, it can be also animation. And it's not only that, it can also be, especially for games, dialogue and quests and many more. So basically everything that you can do manually in theory, especially if it's like scalable, it's a good idea to think about PCG as a possibility to help you with that. How do we create PCG basically? And I would say you define that in three different categories. First is an application. So application is something like a Maya plugin, PCG Crowd. So instead of, having hundreds of people that we put into a scene, animate each of them, give them a path, clothe them differently, and so on. We use Golem to do that for us, like a plugin that basically, you give a path and then it throws people at the path and they walk the path. Same thing for cities. Obviously, we can create a city, but it's often, especially if it's in the background, it's easier to just use, for example, a city builder to do that. The second part is something like a framework, something like a node network, basically. Golem has a part of that as well, but usually a node network that is more integrated into the software. Basically, what you can do in Maya with the node network, Houdini, and obviously Unreal, that is like deeper embedded into the software, so you can really modify that. And then last but not least, we have coding. Things like Python, C++, and so on is basically what allows us to really do basically everything that we want in PCG level. So what we talk, especially with Paul later, is more in the middle. It's the framework part, the Unreal PCG framework. And if you see from the application framework, like node networks and coding, you would basically say the application is the most restricted one, but also the simplest, because everything is predefined. You just try to follow the guideline of the software of the plugin. While with the framework, it becomes more open. And then with coding, you basically have more or less 100% freedom. You can do whatever you want, whatever you can code. But obviously, you need to learn coding. You need to learn algorithms more and more, where in application, it's predefined and maybe like packaged basically at the end of the day. An example I can see here, the first application, Golem. It has a node network, but it's very Golem-ish. It's very its own, basically. And then you can create your armies and your crowds basically using that. Where, for example, if you would use a framework or shading network, texture networks, you can basically create things like ropes. You can create rust, and you don't need to use a texture. You can literally generate that from nothing using like patterns and data that you generate using node networks, for example, in Maya and Houdini. You can do that in basically every typical environment. And last but not least, you will be encoding. So one of the things that we do in Python for Maya is procedural forest. A thing that you do here, we have like 4 trees. And what we do is we write code to distribute the trees and create this kind of forest like environment. And in this case, for example, every forest that we generate is randomly generated with following some rules. So every time we would execute this script, it will generate a new forest. So we can like literally iterate as many forests as we want until we find something that works with the final camera. And that's basically the idea. And that's the 3 big levels of how to create PCG. The question is, obviously, what are the benefits and the downsides of PCG? Obviously, it sounds really cool to create generated content. Basically, a big thing is efficient, sizable content creation. So we talked about landscapes. We can create such a huge landscape just from some input data that, basically with one swipe, we can basically create a whole level for us. A big thing that is sometimes maybe overlooked in that is in procedural is the fast performance time, because algorithm is often faster to process than data, like, a saved file basically. And that is important for rendering. Obviously, offline rendering for visual effects, it's faster rendering instead of like 3 hours, maybe 1. But for video games, obviously higher FPS, so, better performance. And obviously there's a smaller file size. So instead of saving like hundreds, thousands of trees in one file and having like gigabytes of file, we basically save maybe a few trees or a few elements, and the rest is generated. So the file itself is relatively small. And you can see that if you look at the Horizon Zero Dawn example talk, they, for example, to create like a 2D map for their environment, they only used 4 megabytes for 1 square kilometer, basically, which is nothing. What's also cool is you can easily recreate something. So if you create something, you can basically destroy it and you can recreate it without any hassle, and you don't need to save the file or something like that. So you avoid heavy files. Also, you can iterate. So if you want to change something, if you want to change a tree for the whole landscape, if you change the color of a shader, you just change one element, and then every tree will change the color or change the size or whatever it is, basically. So you systemize the content creation, basically. Also, you can adjust to different situations. As I mentioned, basically, what happens if it's like wintertime? Suddenly you have to, change things and custom that. Instead, you can basically maybe add a new element, so it basically changes to a completely new texture or shader or something like that. And obviously, you can create more variety. You can have the same forest, but through maps, you can change where it's different here and different there, and so on and so forth. And it's easy scalable. So if you think about it, so if the object is bigger and since the shader or the texture or whatever is a procedural, it can basically scale with the element because it's not like a resolution-based texture, for example. It's generated. So it's not about like, if it's 5K or not. It's basically, it can scale to infinity as long as the pattern is basically the same. There are some elements where PCG is not so great. And one of the things, it's more technical. So if you work with this thing, and you will see that when we go to Paul's presentation, you need to understand more of like node networks, how to connect things, the logic behind a few things. So it's not sometimes less, what you see is what you get, or at least to some degree, but maybe not as much as you would hope sometimes. And obviously you need a lot of like debugging, which is like literally a part of using the framework in Unreal, basically. And it can be sometimes hard to visualize. And sometimes it can take more time even to create something, but with all the flexibility, sometimes it can pay off in the end. It can be sometimes like generic. That's also a problem with if you do procedural stuff. From textures to shaders to landscapes, it can look boring, basically. Something like this is sometimes also hard to art direct because it's a pattern. So it's not always easy to say like, oh, but I don't want to have this way or that way. There is elements, but it's not always the easiest way to do some. So it can be sometimes less personal. And a lot of times you say, oh, maybe not for the main character. Maybe I should not use a procedural or the main shader for the main character or the main landscape that you will see directly in front of you, because it's maybe a little bit too much that, the same. And sometimes it can be hard to mix between the procedural element and the custom element because they maybe the quality or the finesse is not exactly the same. I think that is probably the biggest kind of downsides of PCG. So it has its place, but it's not like, it will not be like the bullet for every situation at the end of the day. That is the basic understanding of what PCG actually is. So you understand, okay, where are we? What are we talking about when we talk about PCG? Now we want to look into the Unreal framework PCG specifically, and how we can make something like, some of these nodes here to maybe something like this, like how do we get from a few nodes to an environment and so on. And that's basically what we want to look into. And that's why I'll give over to Paul, the Terminator, basically.
There's a new picture of it, so don't you worry, guys. Sure. Thank you so much, Alexander. So just like Alexander already explained, so PCG is pretty much the automatic creation of using game assets and creating like through rule-based and graph-driven workflow. So that it helps to improve the quality, the speed of how you're creating environments, but also at the same time, it keeps the level design in the easiest way as possible, right? So just to give you more context, so the way basically PCG always sort of like has been introduced to, and it actually came with Unreal 5.2. So at the beginning was a sort of given for everyone to try out and play with that. But because at that moment when it started, there were lots of issues when it comes to certain like glitches and bugs. And of course, it wasn't easy to handle. But because with every iteration of how it all ended, it started getting better. And there's still lots of a window to improve the entire structure of PCG. But just to give you more in a nutshell information, how does it actually work? So basically in Unreal, you have usually it's more data inputs, but you can actually usually start with landscape. So once you've got a landscape, then you can actually feed this with point data. So that point data is that PCG graph, right? So that's PCG graph that identifies it, but then it uses the pointer data to also filter through the specific points that you want to work with and also do some more extra modification to it. So however you want it to be placed around, then the points started to kind of react to the landscape position and vectoroids, in other words, for transformations and so on. And that kind of it doesn't have to be just landscape, because once the PCG got introduced, there are a lot more definitely possibilities that actually can be also defined. In other words, it can also be implemented using actors. So for example, you have an actor and you wanted to also generate some points across the meshes that you're currently working with, and anything that relates to the actor, in this case, class, which is the blueprint in this situation, then it also uses that information to feed that using PCG component, of course, into that actor. And then, of course, that's where you can do extra modification. You can either do it through a PCG graph or you can do also inside Blueprint, but usually those two has to be connected in order to work. And the same goes for get spline, because you can actually create a spline, which I will show you that in the next coming slides. There are a few different ways to actually define your PCG graph, right? And also now that it seems like 5.4 kind of finally have some very cool track of new texture, sort of called texture sample. In other words, you can get texture data and then feed this into, get the texture information and feed this into also a PCG graph. And using also that computes the point data. And of course, you can generate some things based just on that texture, right? So it's just like imagine you have a landscape just based on the texture information, you can plot things out on that too. So then, of course, with this point data, we can do something, right? Well, there are a few ways to do it. Well, in this case, in this situation, we're using rules and conditions. So because this rule and conditions are all base nodes, which is fine because you don't have to create these sort of nodes yourself, even though you can. But this is something I will explain in a minute. Basically, you have all the information using those nodes. So for example, you go transform, and also you go boundaries and other parts that creates this different types of patterns, right? So that's why it's very functional in a way to have something for like a level designer or environmental artist who actually comes up with some perfect idea to create some very cool algorithmically random positions of trees, as well as any parts. Let's say you create a forest or jungle, even roads, then of course you can define this by setting those types of rules, right? But at the beginning, it can be a little bit overwhelming because those kind of nodes can sometimes do something similar to it, but then necessarily they do it because it depends how you connect those nodes together. It gives you some sort of different outcomes, but then you can also use those nodes to sort of further optimize your structure of your graph. Of course, with this one, it also comes to a question, what types of mesh formats that you can actually use it for? So the most of it, primarily, it's a static mesh. So you can use any types, as long as it's static mesh that's being converted inside Unreal, like from OBJ, FBX, and so on. It can convert it to, of course, the U asset, which, in other words, Unreal mesh. It basically works with types of meshes. There's also, well, I think it's in process in introducing skeletal meshes, which can all, it's a basic rigged characters, but of course, I think it's gonna come with, I'm not sure yet, but it's gonna come in the next iterations of Unreal. At least that's what I heard from the rumors. But also, what's so cool about that, if you have this kind of struggle, you cannot load things like skeletal meshes, you can always use like a Acto blueprints as well, which is very helpful because Acto blueprint is like a very powerful blueprint that you can include characters that are maybe say animated and then put them into this blueprint, and using this, let's say in this case, static mesh spawner act component, that you can actually define it that it works with these types of classes. So you can actually work with both like static meshes as well as actor blueprints. And then it comes to the second part, I just wanted to give you a bit more information about how things can really work with PCG in general in the process. So let's say we have like an environment, right? And we want to make sure we are setting some sort of like a depending on what type of terrain we have with, and we kind of have a height map for this, or maybe you just define it yourself. Let's say we want to serve some very cool purpose of using PCG. Well, you can actually do this specifically, especially who comes from technical side of things, as well as an artist. You can create your own self sort of like a tools for that, right? But because like what I've explained how PCG graph is really working, by saying those rules and conditions, you can then expose them inside the Acto blueprint, right? And basically using this type of understanding behind it, you can then obviously carry on and break it down into sort of like pieces. Okay, maybe I want to change density, change the patterns, and also I want to make my terrain a bit more flatter, depending on how I want it. It does spread more different variation of vegetation as well as foliage as well. In this case, what's so interesting about it is that because it's all node-based, so it's a lot simpler than comparing to what we usually used to having inside Unreal, at least with an Unreal folks who are on the call, is that you guys know how usually when you used to create something procedurally generated, you basically use blueprints. And for this, it could be a bit complicated, but at the same time, you're going to have to struggle in between how you can create something complex through blueprint system, but then at the same time, it could be very slow and very performance heavy. So that's why, in this case, you guys can possibly, some of you familiar, if not, then for you beginners, is that in Unreal, there are two types of static meshes, right? So static meshes works as, there are more static meshes, but the ones we talk about is the ISM, which is Instant Static Mesh, and the other one's hierarchical Instant Static Meshes. So the difference between them is that you can do lots of identical meshes at the same time, keep within a single draw call, which kind of also helps to reduce lots of problems in terms of performance. The other side, hierarchical, is more like the same thing, but you can use LOD system. In other words, it also boosts extra performance to keep going for you to render something that whatever the distance you are in, closer or further away from something, it will still render something, but the lower quality or higher quality depends how far you are. And also because Nanite, which is virtualized geometry, can also help benefit with that. But because for this, it's still cool, and it should be, because PCGs tend to use those two types of static meshes, is instant static meshes, is to basically, the purpose of this is to still optimize, and also PCG uses as a plugin, uses specific algorithms to minimize the heavy flow of rendering something and popping all the, let's say, parts of meshes on the surface, right? So that's why these two are very critical, especially for PCG use in this case scenario. You might be thinking, well, there's a major difference. Yes, because what I just showed you here, this is HISM, which is the one we talk about instant static meshes. And on the right-hand side, basically does the same thing, but a lot more simpler, right? So you might be thinking, well, that looks very cool, and I don't have to sweat myself just to create something very complicated. I can just do it with just connecting few nodes and make this really happen. So in this case, what I'll do, I got to think of open up on my example. So let me just open this up. So you might be wondering which one is PCG and which one is typical traditional HISM, ISM instant static generator, right? So this one here, this is basically reading 10,000 blocks of static meshes, which are actually stones. And as you can see, it's fine now because it's actually perfectly working fine. But if I start moving around, you see it's gonna just slow it down, okay? And that's usually the case when you start doing something with that many meshes being displayed at that moment of time, because something happens within that frame, all right? We talk about the same number of static meshes, exactly do the same thing, but it just does it instantly. So even though if I move something, you can see it's quite fast. Right? It does everything perfectly fine, even though I know this is the same amount of number of these static meshes we're still generating, but somehow it just does the deal. It just literally works as it should be for something that let's say we want to come up with a very great environment. We want to generate massive amounts of meshes, then we can actually replace it with the idea of that PCG functionality here, right? So that's why, even if let's say I'm going to bring my special profiler here. So I'm going to load this up on Inside. I don't know if some of you are kind of familiar with this tool. So what it does, it helps, especially when you working on games or any projects that requires lots of optimization. You always use this to see the performance it's taking. I'm starting with this one. So as you can see, let's say I'm about to move, and you'll see the sparks starting to take place at that moment of time. So maybe you guys don't know if you guys can see it, but if I get closer, you see these massive spikes, right? So I already have this issue. When I started to move in around these frames, I had a very bad reading of my frame rate. And it also takes a lot of toll on my CPU when I try to load this up. Because usually when it comes to dealing with sort of like procedural generation stuff, it's usually uses lots of CPU as well as memory. And I'll do the same example here, which is our, in this case, PCG. So if I move around, so these spikes here, as you can see, they're not too much. At least they don't reach to the point where it overloads the entire process of rendering something, but at least it's optimized in such a way that I don't have to worry about taking too much toll on the GPU, but mainly on the CPU as well as memory. So you can still work things around when you start dealing with something bigger, this case, environments. And that could be also very effective when you work with something we call word partitions. So in Unreal, with Unreal 5, when it got introduced, there was some called word partition, where you can actually create a very big, massive word inside in real time, and basically cut them into clusters. So every time every cluster reads something, it reads separately, And that kind of clustering system can also benefit using PCG, because you can create a PCG, very cool, on one cluster. And let's say move to another cluster, it does completely separate calculations, and it doesn't have to worry about other clusters that's being rendered around it. So that's why, in a way, it's a very functional, but also very beneficial workflow to follow. So this is like something to kind of look into this if you guys are very interested in more development side of things. So, and also, let me just go back to the slides here. When it came to the point where the types of, as I already explained, the PCG different examples, but in this case, just to show you visually, how much effort do you really need to do something in order to produce the effects you want to do, right, as well. So that's why a perfect idea of getting something that is super, not too complicated. It's just to get to know how PCG really works. So once you know it, then you know which nodes to plug this in and so on. But of course, you can make it more complicated. But for the beginner level, if you want to do something easy and it's there on the background, then you can always set something to end that's such a simple shape as it is presented here. So of course, you get to more sort of creative things. So you can always end up creating like something that it can be controlled in Spline, which I will actually show you that in a second. And also you can basically use this to control it on your own way. So for example, you create a tool, and I want to make sure that tool does, for example, an environment tool. For each tool that, let's say, some grass is higher than the other one, or some grass is scale-wise is bigger and smaller, and you can randomize their positions and based on and some information with using the node structure implementation here. So, and of course, like here, I presented, there's some more defined version of what can be done. Here is that you can actually use also texture data, which I don't know if in 5.4 got much improved, I have to say. So it is very cool and beneficial for folks, especially someone who deals with something like virtual production, maybe even, not just games, but let's say because games, it's definitely, the purpose of PCG was definitely first is game development games, because we're dealing something bigger world, because games get more complicated and more realistic. But another thing I have to say is that also there's a lot of potential who comes from VFX industry, right? Someone who been working with Houdini, doing lots of nodes there as well, connections and logic, you can actually get this more into something more real time, because the difference between having something that's PCG and other ways you use to get used to that doing other ways is that with PCG, you have to deal with something that happens nonstop every time because it renders through GPU. So there is always this open window, unfortunately, for things that can slow things down. But once you figure out how you can process your PCG, then of course you can actually minimize this effects, because sometimes PCG can be a bit expensive on your memory and CPU. But however, when rendering, it still takes a toll, because we still have to render something in a viewport, because at the end of the day, it's a game engine. We're still going to render something on a viewport, but you can actually simplify your sort of like, in this case, connections, but at the same time, node structure, and also minimize the load on the static mesh, which you can be further optimized. So there's lots of ways to work around PCG. Just to generally tell you a bit more, the PCG has also ability to give you a developer like open space of opportunity. So for example, you can even craft your own PCG blueprint. So that this is different types of blueprint we talk about, because this blueprint is specifically designed for users who wants to possibly go a little bit further, right, with their creation. So they don't just want to stick to nodes-based PCG graph. They can create their own blueprint that requires a bit more logical sort of implementation to make sure that maybe that graph will be doing something else. Let's say spawning trees, or maybe you want to create like a little PCG blueprint that helps you, the artist, to add different meshes in the runtime. So every time, let's say you build some environments, you can swap them, because usually inside PCG, you have to get into PCG graph, switch the static mesh, but you can also create a blueprint that exposes this on the outliner inside Unreal. So that's also a very helpful thing. So just to give you more what I'm dealing with here. So this is an example I've created for one of the projects. So this is like a PCG of like a, let's say, call it forest. And you can also, let's say I create this whole detail sponge with all functionalities inside. And what you can actually do is to distribute. So in this case, I'm having grass 100 centimeter away from each other, right? That's why you can see they're slightly being spaced out, right? So in this case, I want to also maybe, I don't know, maybe I just wanted to increase the space or make it a bit closer. I can set it to 50. Of course, going to take a bit longer, but it will definitely get there. So because you also have to remember that we're dealing with something that is constantly, instantly being generated. That's why it takes longer. But once it processes through, it'll be fine, right? I think I put a bit too low number because it will get too close to each other. So we're expecting more to spawn next to each other. Yeah, I guess I have done a little bit too much. So yeah, so it's doing something. Yeah, it's doing it. It's calculating. So you just have to always remember, be very well. Yeah, so now you can see, of course, the performance is still a bit slow because obviously we're dealing with something too heavy, right? But in this case, what's so cool about it, I can also view how many objects has been spawned at that moment of time, okay? So let me just load up my PCG, and I can just go and view them. So I go and inspect it. So technically, it's taking time. So this is called inspection. And what it does usually, it tells you how many positions of each point has been literally generated. So at least you can see 215,000 points. So this is quite a big number. That means literally in this scene, we talk about 215,000 meshes just for the grass. Even though I'm currently running on 4090 graphic card, and let's just open this up on the show FPS. Of course, it's running. I'm not sure if you guys can see something at the moment because I'm not that close to this, but you can see it's a bit slow, but we'll get there. I think because I moved it. It can get a bit buggy. I think it's fine now. Yeah, okay. So you can see as closer I get, of course, it's gonna be, you know, a bit faster, a bit so further away I go, it's slower. But that's something quite obvious because we're dealing with something, lots of objects on the scene. So then, of course, because this information is very useful, then you know that you're dealing something, the number of points that it's been assigned for each mesh, right? So each mesh is assigned to each point, and it will basically give you even information of its position. So whoever develops something, and that's very, very useful when you're dealing with PCG, it's like you can create a PCG blueprint that it can analyze as well. Like, for example, because it's spawned at that point, and maybe at that point you wanted to do something else, right? That can be also done as well. But because it's a bit more complex, but just for in the nutshell, it gives you some information that you can actually have a bit of that freedom to not just generate stuff, but also create something very complex and then define this with those numbers here. So that's something cool. And also what it tells you is more information that it gives you more info, what types of meshes has been spawned at that period bit of each point, right? So that also gives you the analysis here too. So that's why knowing that you can actually create some things like that, it's quite useful. And let's go back to another thing, which is the PCG blueprint. So this is an example I found on the internet, which I actually modified this. And this is your entire PCG blueprint. So imagine this part of, you can see meshes that's been literally spawned here. I actually use this to define which meshes I want to use and assign them. So every point is being picked, and then it's going to be fed with each meshes. All right. So in this case, I can just turn off, you know, and I'm not sure if you noticed, guys, as well. It's a very interesting thing is that this grasses has two separate colors, right? And what is, it's just loading. Give us a time. Because I made this scene very big. That's why it's like kind of a bit slow. So, and let me just make it a bit smaller. So let me just use those points, right? And I'm going to just minimize it. And that's very cool because sometimes if you have too much performance issue, you can always minimize this scale of these PCG here by just turning off some of those meshes which you don't want to render. So I can switch it back on. It should be perfectly fine. So usually PCG always also have this problem is that every time you scale something up, obviously it's going to be slower, which is kind of obviously normal, right? So now things are moving forward faster. But as you can see that each grass color has a bit different formation. So in this case, you can also define it different types of patterns you want to work with. So for example, I wanted to use this different types of texture for this. Even the texture is the same, sorry, but you can change the scale of the pattern. And of course, in this case, you'll see that it will change this position, right? And so on. So that's why PCG is very powerful because it gives you this opportunity for you to load things up in such a way that you can really work a favor for you because you can be also creative on that section too. So Yeah, so this is like the pretty much how I can say this about PCG in general.
Interesting wise, basically, like Unreal is obviously mostly for video games, and as you said, for pre-visualization, for example. But again, there is a slow trend to start to use Unreal for certain shows. If you have maybe not the high polished whatever show, you can think about Unreal because faster rendering times. So if you don't want the Star Wars experience yet, pretty good, but maybe not the biggest show in the world, you can think about, hey, maybe Unreal will do the job faster and more quicker, even for my visual effects animation project, basically. So there's a lot of adjustments, and also at the same time, PCG is a concept first. We just use it as I start to tell. You can literally go into Maya and you can create procedural content generation. You can create custom textures in Maya, in Houdini, everywhere. You can. The concept that Unreal introduces in its framework it feels very Houdini-ish. For example, it has a lot of this kind of like principles and patterns. So it's not something that is only related to Unreal. You don't need to go to Unreal to use PCG wherever. You can basically use it in Blender, and every software has elements. But obviously, some of them are less, as for example, Paul just showed us. The framework allows us, instead of creating this big node tree, it like summarizes all this big node trees into simple, actor and doing something and point cloud and whatever. So a framework like an Unreal allows us to use procedural content generation simpler and easier. It's probably more artist friendly than if you would open the node editor in Maya or Houdini and start your big, distributing points and whatever. So that is the big difference. But it's not only like in Unreal, and that's it basically. We have a few questions. I want to start a few questions that I noticed when I started to look into the topic, and afterwards we will open the question for everyone here, basically. So Paul, for you, the question. So PCG usage. When is the best and at the same time the worst time to use PCG? What is the point where you say, you know what, great, not so good?
Basically, let's put it this way, right? It's a kind of question comes to my head every day when I do a deal with this. So basically, PCG is still, I wouldn't say it's great, but it's great for, I would say, prototyping, but also creating very cool. I think the best way to put use this framework as a developer. It's great because you can actually experiment. There's unfortunately still problems that comes deal with not just rendering, but also generating these points properly. So every time you load something like a very complicated meshes, then obviously you're dealing with something that the GPU cannot handle. So you need to be always having powerful PC for that. Because if you end up something with the lower specs PCs, I would not recommend go too much with the PCG. However, you can create a PCG really nice with PCG framework. Then you can, let's say, create like a maybe very simple game, or not even game. Let's say you do something mainly for visualization. Then you can maybe use some assets which are kind of lower poly counts. And also, keep in mind the texture size can also deal with lots of rendering, because we're dealing something that is GPU based too at the same time. Because what we know as a PCG, it's always been very known for content creation, and it's a procedurally content creation, is that those things end up always be heavy on CPU and memory as well. But because rendering using graphic cards, in this case, because we're doing something with real time, and this is because it's a game engine, it also helps to benefit if you have a good GPU too. But I would definitely say when it comes to use of PCG, always be mindful you have enough memory as well as CPU with good graphic card, so that it can handle this very heavy computation. Because remember, we're dealing with something that every point has been rendered on one frame, right? So, and then every point that's been generated, then it literally feds to the static mesh, which then pops out and distributes across this entire structure. So I would say, and in a very short answer here, is that the best time, if you wanted to use so create some environments, let's say you do it for visualization, then I would say create like environments that are not too big, right? So something not too majorly huge, because you're just going to focus on certain angles, of course, when you do some visualizations or movies and virtual production. But when it comes to games, deal with something that's a lower poly count, right? In a worst case scenario, I will not go, let's say, PCG, because let's say if you want to create a game like big massive world game, then maybe you can use word partition system inside Unreal. But I will still be very mindful about it. Is not to go too much with the PCG's, I would say, potential, but also try to be as optimized as realistically can be possible.
Just to understand, so you would not recommend it at the moment as like the final solution, like in your game, basically. So what you've done, besides the concepts and for the visualization things, would you, like, for example, if you create such an environment and you say maybe the performance would you then bake it, or would you basically use it as a template and then create manually like lower part and whatever, like, kind of?
There's another thing which I forgot to mention as well, is that if you're dealing something with a massive scale, in this case, let's say you have a PCG, you can actually turn it into like instance. So in other words, you can kind of call it bake it. So it's not baking, it's just basically turning into like an instance. So once you say you're happy with what you have, then you can turn into like one massive PCG, which is no more longer PCG because you don't need to use PCG to generate anything. It just turns into this one massive instance object. Of course, there's no more window for you to operate on it, in other words, change something. Then obviously you have to do again PCG. And that's where its complicated part comes in, because every time you scale something, populate in a massive detail as it's bigger places, then obviously it's going to crush it. So you just have to be always smart about it.
How technical is it to use PCG framework in Unreal? How would you, like, if like an artist who's not really familiar with the big, like, blueprints and whatever, just like more familiar with the basic stuff in Unreal, would they be able to use it more or less tomorrow with a few tutorials, or is it literally like you need a little bit time to get into node networks and the technical aspect and whatever?
I would say this, as an artist, I would definitely recommend people to get into pretty much go into basics, because you can actually build some very amazing environments just using like maybe up to 10 nodes, maybe 5, depending on how complex that the environment is. It's just you have to understand how basically PCG works. So you have to always keep in mind that, let's say you create an environment, and if you're using landscape data, you have to use landscape data, because usually PCG only works with landscape data information. But you can always make sure that it only works with any actor data. So it doesn't have to be landscape, it can be any mesh you can generate on. But you just have to define those rules inside a PCG graph network. So this is, I would definitely say to most artists who deals with that, is to at least memorize few nodes, what each node does. Make sure you comment them at least if you don't remember. And once you plug them all together, you can create a stunning environment just with this very few, I would say, connections with up to like 10 nodes. But when it comes to more of a developer side of things, then definitely it's a great place to start with something, because then you know how you're using PCG Blueprint, you can manipulate each point and maybe you can define them. And based on the information, you can also say, okay, I want to have a specific structure. So because you can also, I'm not sure if anyone's aware about it, you can actually use PCG to build buildings too, like for architecture. Even though I haven't seen really much architecture visualization PCG, possibly they are, but in general, like doing lots of intense research and doing this stuff myself, I realized I also can create very interesting buildings. I wouldn't say it's kind of effective because buildings can vary depending on what you're dealing with, but you can actually create this very cool PCG blueprint where you can set up, okay, maybe this is the different color of a brick or something like that, or maybe there's a different window at that specific point. So I would say for the artists, because at least I'm thinking about level designers as well as more environment artists or artists themselves, they can basically use PCG very friendly. And there's lots of good tutorials out there. And surprisingly, while I was writing the book, I found out they're very cool tutorials, very in the simplest way to actually give a little bit more info and outline on how you can actually create something using just very simple nodes. So there, I think I would say 100% is not as technical as most people know. You just have to understand some rules and how you use the PCG.
I mean, that's where the framework comes in. It kind of, compacts a little bit more. So it becomes, as you showed, like, not this big node tree. It becomes this like four nodes, basically. What is the biggest challenge using PCG in Unreal? Like, what is the biggest struggle that you have basically as a user?
I think I need to come back to this again. So like we cover in usage, it's an optimization. You just have to, we all have to understand that we want to create amazing, beautiful environments. But one thing for certain is that there's a certain limits to how much it can be rendered on the viewport, or like, and even depending on what resolution you're dealing with. And unfortunately, PCG, it sounds perfect. It's amazing tool. I would say use it, but One thing I would say, it's you always have to just bear in mind, be very careful when you create massive environments using PCG. You can also create, like I mentioned before, to bake those into instances and you just use them. But what if you need to do something and all of a sudden you need to literally go back again to PCG and redo formation of your foliage, for example, or add some few bits and pieces. But however, with 5.4, and I think 5.5, they'll be also coming up with some extra solution that you can actually individually change the positions of each mesh. So that's helpful too. And actually with 5.4, you can actually kind of already do that. So you can, let's say you have PCG, all the structure with the trees, and you just wanted to some of the trees to fall. So you can just pick up all these, some of these sections, or is it like some of these meshes, and you can just manually change them as well. So that's very cool too. And I think they introduced that for the case, like people have been having so much issues that every time they have to generate something, they have to do it again. But now you can actually set these individually. So that's as a plus thing.
So basically performance and to some degree still the development bugginess side of the Unreal framework engine.
Yes, surprisingly, at least that was from my experience, when I was testing between 5.2, 3, and 4, I noticed 5.3 was kind of more stable than 5.4, at least for me, in terms of performance. But I think because they are now keep improving now with PCG framework, and I'm definitely looking forward because I can see it's a huge future with the PCG. You just have to be, as I said, smart about it, but also need to find the ways to optimize this and also be clever about it. And I think in the future, definitely it's going to be a massive, amazing tool to use.
Maybe not everyone is using Unreal. There's obviously like Unity, CryEngine. Basically, that's more or less it with a few smaller things. Can we create PCG in other game engine? Are you familiar with that? Obviously, we can, again, like put nodes together, put programming in, but is there like a framework as it is in Unreal?
There's no, I don't think, after doing lots of research on all that bits, and they've been using Unity for a while, a long time ago. But now I think there are some tools which you have to buy, and their asset store, we call it, so which can help to do this. And there are most of these developers who actually engage and provide these kind of solutions, but they have to be done as a third-party plugin. Because PCG is basically built in as for free, and I kind of can use it. But I found some in the Unity, some of these do exist, but I wouldn't say in not such a way at what's presented in Unreal.
You can always go with Python or C# or whatever the language is, C++. You can always PCG that into. So a lot of times you can do it visually with Noteworks, but there is, as far as I also know, like Unreal is so far the only that really has a framework made for that as a predefined.
Yes, exactly. Because one thing for certain, what comes down to is that PCG framework is a very powerful tool inside it. It's still something that can require a little bit extra attention to fix some of these details, but certainly I have to say it's actually the best thing that I've seen so far out there until dealing with this kind of thing. Because honestly, like when it came to the back in the day, you just have to use the so-called, we call it the foliage tool inside Unreal. You just have to populate and paint over with brush on the landscape. It's all work, but of course there's a slowdown in performance as well once you do it too much. But with PCG, there's a lot more control. So let's put it this way. It's more of a sort of a kind of tool, I think, be a plugin for anyone who wants to have a further control over things that they cannot control, especially with foliage tool. There was some sort of control, but not as much, not to the same level as what PCG got to offer.
Idea of today's talk is also a little bit like, on one side to talk about PCG as a concept independent of where you are, if you are in Maya, if you're Houdini, if you're Unreal, to understand like USD, like AI, like scripting. There is this concept of procedural content generation that can help you to speed up your process. You don't have to be only landscape level designer. You can be a modeler, you can be a shading artist, texture artist. It's basically like, in theory, it could be a lighting artist, like, you can paint your lights through that. And to some degree, if you have a city and you have to light a 500, 5,000, 50,000 lights or light dots, that's not fun to do it by hand. So it's on one side that, and obviously the other part is to look at also in terms of game engine, but not only for games, maybe game engine for pre-visualization or for smaller environments. So that is the main idea of the talk. Before we dive into the open Q&A, let me quickly, as Paul mentioned before, he's currently writing and wrapping up his book, Procedural Content Generation with Unreal Engine 5, which you can find on Amazon. It will be out on November. So if you're interested, you could probably wishlist or something like that there as well. So you can find it there, and obviously like on his website. He has also a YouTube channel where he also explains a little bit more into PCG and Unreal. There's a few episodes. You have to crank up the volume to hear him.
My bad. There's an issue rendering this out. Apologies. Next time it's not going to be the case. So apologies for that.
Yeah, so that's the only thing. But if you do it, you get a little bit of an introduction, a little bit what he just did, but more like step by step how to create your first environment, basically. Also, I personally like the procedural content generation in Unreal Engine 5 GDC talk. Was really nice, really cool. The Horizon Zero Dawn GPU-based runtime procedural placement, where they talk about how they created landscapes and how they optimize performance and so on and so forth. And as I mentioned before, a big part of how to do PCG independent of where you are. If you don't want to use the Unreal framework and you want to use it everywhere, you learn things like Python. Python is basically everywhere. Sometimes you have to be C++, but scripting is basically the thing. So you're welcome to join us. We have Python for Maya, Nuke, Houdini, and Max. And that is basically it from our side. Now let's open up to the meetup.
PCGs, can these be applied to architectural renders, whatever? And I guess the second one is more in relation to actually a project we did quite recently, which had quite a large expanse of trees, and it was a build. It's for virtual production. But what was in camera, because the building was 2 floors, when we were on the first floor, we saw quite a lot of, I guess, the foliage and trees that had been generated, which was very heavy and actually caused some issues for the machine. So I do understand your point to, needing to have a pretty beefy machine, but I guess it raises the question, a lot of optimization was needed to be done, and maybe what was in the distance didn't have to be such a high, poly count, I suppose. I believe that's what may have resulted I believe it was done using PCG, hence why it just replicated a lot of this foliage and that's it. It looked great once the optimization was done. So I'm just kind of curious to how that could perhaps have been done better to avoid I guess it's a big lag on a virtual production wall.
Yeah, sure. Thanks, Roy. Appreciate it. Nice to see you again as well. So I have to say one thing. You can use for architecture. You can try it. It's just mainly it's about how you are sorting out your first models, because what we know as well, architecture is not the easiest thing in terms of optimization, but also keeping good quality. That's one thing for certain. So if you want to do something architectural, you need to be very smart about what is it that it's very important for you to view it in the front of you as a rendered this out, like when you try to do something real time, right? Right with the camera. So keep this in mind, because if you want to populate all the buildings around, let's say a city, then PCG can work, but you have to always keep in mind that some of those buildings have to be very low poly. You just have to literally follow the formula of using high quality materials that has very cool, effective I guess, the best way to put like a look that it has 3D parallax techniques. Another thing I would definitely say is that if you're constructing a building, you can actually do that. You can even create like a tool for that using PCG, because I've done it before. You just have to basically create like, okay, each floor has this specific segmentations. Okay, I'm doing foliage on top. All right. I'm doing this section. Okay, that's fine. And of course, the rest parts around this architecture can be kind of like optimized. And you can actually do that with PCG using hierarchical instancing, which is already in there. But for example, you can, as we just talked with Alexander, you can back that section and just the rest of that turn into like a sort of new PCG, which basically it's all low poly buildings. So it's all about this kind of little things. It's all tricks. Like literally, you just have to be smart about, because at the end of the day, you're not creating game. You guys from virtual production. So you just have to be literally effectively thinking what angles you're working with and what objects you want to be particularly very interested in, right? To follow your storyboard. in that case. So I would say PCG definitely is very useful for virtual production because we send this test done with that too. But one thing for certain is to be very sure what exactly you want to do, but maybe create just a structure with using PCG. That's absolutely fine. And the rest of those objects around it, create another PCG or maybe use the same PCG, but with a lower sort of poly count objects. Yeah.
It sounds like a little bit more like LOD, like level of detail kind of a question, because at the end of the day, like what you described, it sounds more like, hey, we don't want the background to be too high poly, so it drains the kind of, so because at the end of the day, I mean, how much can PCG actually help in terms of performance on because if it's kind of like it helps to generate it, not automatically will make it lighter.
Of course, but that's where HISM, that's hierarchical instancing, comes in, because I'm not sure, if maybe I missed that part. It's like PCG generates their ISM as well, HISM. It's just because automatically set to HISM, which is the hierarchical. So that's why every time you load something in front of you, depending on how LOD is being generated, depending on the distance, you get that level of details and that instance. So that's why in here, like I was saying to Roy, is that you can keep something in high quality just in front of you, because you can even just create a separate PCG for that if it needs to be. And then the rest of PCG just turn it into something that maybe it would be high poly or low poly. You know, just like in between leverage this.
That is a good point, because in the optimization, what they did was manually intervening the further, I guess, distant objects, and then reduce their poly counts and optimize it for the wall. But that is an interesting point. So creating separate, I guess.
Exactly. Yeah, sorry to catch you there. I just forgot. I forgot to mention, there's a new node that's been introduced that you can actually optimize it depending on what types of performance you're working with for your PC. So for example, you can go cinematic, you can go like epic, you can go high and level and so on. You still need to find a way how to figure this out, because this works for the rendering purposes. But it's just like for anyone who's interested, there's this extra node that's kind of got introduced. I didn't see in the 5.3 go introduced with 5.4. And I think they will be doing that a lot more these days. And even though if let's say you don't have that, you can actually create your own types of nodes. Like I showed you guys with this PCG blueprint.
Yeah, thank you. Appreciate that.
No worries, Ryan.
This is again related to virtual production. I had Paul, thank you, and Alexander, thank you for doing this. I had recently a virtual production output where we are using Chroma green screen virtual production, where I had to generate palm trees, rocks, and grass. And I used the Brushify pack to generate the landscape, on top of which I then generated instances of PCG, a couple of instances of PCG. Immediately my system tanked and it used to keep crashing, and then I figured out using how I was going to optimize this, and then I realized it's because of the world position offset that exists in the foliage in one of the assets. And also I used Megascans, which was causing a lot of bottling of resources towards producing this output, where I was getting FPS somewhere around 4 FPS, 5 FPS. And the minute I changed I knocked off the WPO, world position offset, I was getting 40 FPS. This is building on what you told Roy right now, all right? Where you're saying if we were to generate a separate PCG for something which is closer to camera, and then use the larger ones to kind of take care of LOD, as well as take care of perhaps a low poly example. Is that the only optimization? Because there's a cooking aspect of the pipeline that we have in the studio is axiometry. So Unreal Engine to axiometry. Yeah. So when we're using that pipeline and not using vanilla Unreal, I seem to be having a lot of problems. I'm not sure if it is going to be also in native Unreal, or is it specifically an axiometry problem. But I'm trying to build it, and then when I build it, it crashes because I'm using UDS, Ultra Dynamic Sky. So my lighting needs to constantly change because it's an island. So it's not like a controlled room. So it's a large island where I need to have sunset skies, and I need to be able to move to other parts of the island and then move the sun. So I'm finding cooking time and building time to be exorbitantly large. And in all the previous projects, cooking time and building time has had at the most gone to 20 minutes, 25 minutes. This time it went to 5 hours. And I don't know how to circumnavigate that. I don't know if I should be building it. So my question is basically optimization. All right. You spoke about an instance method. All right. I know there's a generate, clean, and clear PCG. All right.
Yeah,
When you say instance, do you mean in the static mesh spawner? In the attribute instance, do you mean to use that?
No, there's a very cool, which I need to remember because I don't remember where. But so basically, if you go using PCG, you can right click and there should be a, I think it's called convert. I can't remember because I need to find this again because I don't really use this. It's only the time because every time I work with this, I tend to every time have this runtime nonstop generating. So I don't really do this. But if you have something like that, you can actually, I think it's called save instance. Yeah, if you right click on a PCG, I think there's an option there. If not, because I remember I did this in 5.3. With 5.4, maybe slightly bit different. There's a chance to change this into an instance, and you can actually bake this in your scene and just let it be. And then you don't have to use your PCG anymore.
You mean to say I can stop that PCG instance and take it off the world outline, take it off world outliner, as such?
From that volume, yeah. So literally, you can then remove that, yeah. So you just basically save that. So it will bake it on the scene, and then you don't have to use this PCG. So you can actually do that. I just remember how, because I've done a few times on the 5.3. 5.4, I think they've changed that because I've noticed every time you work with the newer iterations, they change sometimes some of that even not start to disappear because they got deprecated. So it's a bit annoying. Because of this, I even had to change the content of the chapter because of this.
Yes.
So
I believe thanks to thanks to teachers like you and say Eliasz, whom I've been following about PCG, right? There's been a lot of improvements. There's execute blueprint, attribute noise is now something else, So it's a constant stream of learning. So we don't come from.
It's a constant learning, because I know. It is true because it can be very annoying for VFX as well, which turns into real time, and it can be a little bit not something friendly. So that's why for game developers who can handle it, but when it comes to dealing with the especially who comes from VFX background, it can be a bit annoying as well. So I can imagine that.
That's a question. There is a clear PCG option on beside generate and clean up clear PCG. All right, that generally makes like a photographic image of the same PCG, which means you can keep the PCG muted underneath it, right? Can you delete that and will it still work?
I mean, you should be able,
So you can leave the stamp on, you can leave the photographic stamp on, and you can delete the PCG and it will still work. Is that how it is?
You should be able to, because you create, I remember stamping. Yeah, you can create a stamp out of this. Yeah, you can. You should be able to. I don't think it should be any problem, at least from my memory.
Okay, and then when you cook it, and when you cook it for for virtual production, when you need to package and cook it for virtual production, it should be fine, you think?
Yeah, because if it's already stamped and it's in the scene, there should be no problem, right? So it should be all right. I mean, you can always give it, because remember, if you save it, it should be okay, because a stamp is a stamp. It's a separate. So in a way, it's like a cache something, your PCG, and it just stays there on the scene, and it shouldn't be removed. So at least it's stamped, because that's the whole point of instances there. So just you keep the quality of the same look of your what you already created, and the only time you use PCG is the time when you're trying to form a new environment, and then you create another stamp. Yeah, just check this, because it remind me. Sorry, it's just called stamp. Yes, that's the one. You just check the stamp, and that should be fixed the problem. But just check it out. I guess you can always reach out to me if you have some questions. So there'll be definitely good luck with your work.
Thank you.
Sounds very intense. Very intense. Yeah.
You guys can find us obviously on LinkedIn. You found this event, so you probably know where to find us on LinkedIn. So if you have more questions, especially probably in Paul's direction. Also, something I always say, basically, at HISM, same thing here. Literally, you can test it. If you have a question about something, you know a concept, and you're wondering if you do this, that happen, then you basically just test it out. And same thing with Python. If you're not sure if you can do things in Python, you just test it out, and Python will tell you. Same thing with PCG. If you want to delete something and still wondering if something else is preserved, delete it, see if it's preserved, because that's often that's something I obviously sometimes concepts can be difficult, and that's why this question exists. But sometimes it's just hey, can I do this? Try it out, and you will often the software will tell you if it's working or not. Basically, it's often like the simplest way.
I'm just curious if you've encountered any projects using it for crowd, or I think it might be on the horizon, as you said. Skeletal mesh might be coming.
Yeah, I was about to suggest, because I saw your question before I was talking to Sharon, right? And I saw it, what you mentioned. I was like, oh, actually, this is a problem I was working on a few weeks ago. And I show you, I got tutorial on that on YouTube as well. So let me just show you what it looks like. So basically, you see these characters here. This is like literally, those are the they call it character blueprints. So they have their own logic to walk around by themselves using a little AI, very cheap AI, sort of like the script. And so in this case, you can actually, because for this one, I use this method, which I found a very cool YouTube guy as a game developer. He gave me some ideas and how you can actually turn your characters into flipbook. I'm not sure if you guys follow me. So you have, let's say, an animation of characters, but because it's all skeletal mesh. And the problem with you, when you load this up as a skeletal mesh inside PCG, because we have to duplicate each character, that can be a bit heavy because that works on your GPU as well. So that can be really a bit complicated to load them up and literally render them on the scene. That's why it can drag your performance, but also unfortunately reduce your, in this case, FPS count. So in this case, that flipbook was an idea where you can actually basically create like a, let's say, character. And so in this case, I have like some character from XAML as an example. So in this case, I'm presenting how actually you can do this. So you can actually, let me show you. So I create this little quick tool to preview your animations. So every time you preview it, then you can also assign different types of animation you have on for the same skeletal mesh. But in this case, I want to just use this to preview it. At the same time, when you preview it, then you see your characters can, let's say, move, right? So you're going to see maybe in a second. So maybe it's going to here in this case. So when you play it, let me just check here. Yeah, so I think it's one of them. So let's say you are playing your animation, right? So depending on what type of frame rate you want to work with, then you know that there's let's say you work with 60 FPS, right? So that means this part of animation, you have to bake out each pose of this character at 60 positions. So that's then a way to optimize and using the flipbook idea, where you can actually then use this for your sort of like a crowd simulation inside using PCG Blueprint. So that's another thing. If you use the skeletal mesh, it's still okay. But the problem is, as I said, skeletal meshes can be a little bit too expensive to load them huge crowds. So that's why I would not advise to do it. However, there's a cool, I heard there's with newer versions of Unreal 5, I think 5.5, they'll be releasing that GPU Nanite. So in this case, as you can see, I'm presenting that section. So if you guys are interested, follow this on my YouTube as well. I've explained it. And I think I also include that this tool thing inside that tutorial. And you can actually use this idea for your crowd simulation. And also in this case, I create this logic for your AI system. So, and if I go back now to this main thing, then you should start seeing your, with a very simple PCG section here, like here, like I'm here presenting, like it doesn't really, it's not complicated. It's only a few nodes. I've just connected all of them. And I'm only spawning those actors. That's pretty much what I do. So, and if you can see it, they all kind of walk around on their own thing. So you can create something out of this, even though this AI is a bit stupid because you can program in a way that you can basically make them, like make their own business, but they don't, stop at each other. But in this case, just for this very simple presentation, I actually created this little crowd simulation that literally runs at like 100, even 100 FPS, depending on what PC you're dealing with. So that's a very cool achievement, right, with this kind of idea. So basically, in this case, we're not using skeletal meshes. We're using a bunch of static meshes that turn into like a flipbook. So every time it reads through the array of all these meshes that are being connected together, it just iterates them every single second, like literally every frame, right? And then basically you do all these, and that's why maybe, as you can see, they all get stuck there. But the animations of these characters are kind of a little bit 24 FPS. And of course, it's just for the presentation. You can make them even faster. But as I said, you need to bake all of these poses of that, let's say 60 frames animation. So, this is one trick. There's another way to do this with vertex animation. But vertex animation in Unreal, especially the latest Unreal 5, you need to 5.4, 3. It's kind of buggy and glitchy. And there's some, you need to fix this like literally down to the bone of the Unreal scripting. However, with 5.1 and 2, I've seen some good examples. It works, but you have to be hacky about this. So I saw this solution. It kind of really perfectly. It works fine. It really works fine. And I'm telling you, like, when it comes to crowd simulations, like let's say you want to create a zombie effects, then obviously it's amazing for this stuff. So that's why it's very sort of useful for this kind of thing. So it depends what exactly you're doing as well. It can really, like, usually the question is raises in your head, what is it that you're working with as well, right? Because sometimes you have to always answer yourself, what is it that you need to? What is it that you want to do, the purpose of this? And also how many things you wanted to actually include and maybe work them together somehow to make it work. So it's all lots of, you just have to answer to lots of things to that. So yeah.
I mean, your example was like perfect for like background. It looked exactly like old FIFA where they were like stuttering,
yeah,
basically. And it doesn't matter as long as you see pixel like moving and doing things that is like variation, like, if that would be like an example, maybe you see a building in the background and you see people like walking like in this through glass or whatever. You don't care if it's like stuttering or whatever, as long as it looks from afar like it's like, variation enough, then I think that is like already would be for this. But obviously if it would be like 20 meters away, that would not work with
of course,
something like this.
As we remember, like we were talking about that, it's all about LODs, like depending how far you are, because you don't care, literally.
I just definitely have to bring a count every time we talk about a topic like USD, PCG, how often we mention this word, this acronym. I think it's probably like, in the hundreds.
Thanks for doing the presentation. It's really good. Thank you. And I'm coming from a beginner background. My question is kind of similar to Alex's, where he kind of asked what the biggest challenges are. I kind of just wanted to ask, what are the most kind of common things, any kind of sort of common challenges you might face as a beginner, as one starting out, experimenting, playing around with this?
As a beginner, make sure never scale too much, right? With your PCG, just be very careful because it will crash your computer. And then when it comes to spawning objects, always try and see if you can minimize the numbers as well. And also because once you get into like tutorials, and there's a bunch of good tutorials out there before my book releases. Also, if you're interested looking into, is that there's also information where you can find about how much how many objects you want to be spawned, depending on the distance from each other. Like I showed you guys this example, the grass where you spawn something that's 100 centimeters away from each other. You can expand that a bit further. So that also reduces the number of any upcoming crashes, let's say, right? So it's you always have to keep in mind, it's just don't go too much on scale. That's the first thing I have to say. Otherwise, you're just going to crush it, right? Because there are cases where you forgot add some values to that, or even like you set it at 0, because it's the most biggest mistake I've noticed, especially when you're a beginner. And don't get me wrong, I've done this so many stuff. It's just so many times, just because sometimes you just forget. Let's say you create a PCG and you want to pin this together as a component into your blueprint, and you expose this and the blueprint, and you put in your viewport, and then you always forget set float to something bigger than 0. Because if you set this to 0, goodbye. You just have to kill this entire, Unreal. Use Task Manager. Just kill it off. We're just not gonna even do anything, because remember 0, it's like we'll treat it as an infinitive, right? So it's gonna basically try to populate for 1 point. Yeah.
So basically, it's like in our Python course, it's the never use a while loop kind of situation.
While loop.
It's basically the same thing. Like use for loop, because it's basically very hard to crash. While a while loop that's the scale in PCG is like don't scale too much, so else you will you will easily kill yours. Like that's the while loop in Python.
That's why it's interesting, right? Because it's literally like you do the visually programming as well. Sometimes with PCG you can sort of treat it that way, with just with nodes, but you always have to keep in mind it's just numbers. You always have to put them in. It's just never go anywhere lower than, let's say, 10, or just always go higher, let's say, than 50 or 100, just to make sure you're not gonna literally block your crush your project, even computer. I just want to say thank you guys for being here and listening to me and all this, and then hopefully you guys found it very useful. And at the same time, I wish you all the best. Keep grinding, keep learning. Get into PCG. There are cool stuff out there as well. Don't go too much sometimes. Just like as Vish mentioned, just always be careful as a beginner.
Check out Paul's videos and on YouTube. And obviously, if you're interested into diving into deeper into that, his book is coming out in November. But independent of Unreal or not, it's the same thing like with USD and whatever. Keep it in mind as a potential tool for the future. If you go in Unreal, if you go in Houdini, if you go in Maya, it doesn't really matter. Things like Goliam are basically crowd simulator that are basically PCGs at the end of the day. They actually have node frameworks that you can connect similar to the Unreal one just for crowd. And so keep that in mind as a potential tool or something that you can use. And obviously there, as I mentioned, there's multiple ways to skin a cat here. And it's not just a framework. You can literally do it via coding. You can do it with basic node networks from Unreal or Maya or whatever. So just keep in mind that not every solution needs a manual work or whatever, that there is this procedural content generation that is part of this new or more modern way of AI and USD and whatever, basically. And that's what we wanted to show you guys, and have a look in the future of how you can improve your workflow independent of if you work in games, animation or visual effects. Thank you very much, everyone. Thank you very much, Paul, for being with us here and showing more in depth into how Unreal works with this relatively new framework, still a little bit in development, a little bit buggy, also partially still, but I think it's something that will be coming in the future. And I think also a lot of other game engines will add some kind of PCG frameworks, probably more and more, because of the performance, because of the simplicity to create content basically at the end of the day.
I welcome you to join us live and also watch the previous episodes, and I'll see you on our next TT Meetup.